everyone. Today is the second part of NEET series. So I have some questions of NEET previous year questions. So let us start. It is based on thermodynamics. Very first question we have, which of the following are not a state function? Okay, so let us check them out. First, Q plus W, this is equal to del U. So it is written in capital letter. It is capital letter, and capital means it is a state function. So this is equal to internal energy change. So it means option 1 is incorrect. It is a state function. So from A, B, C, D option, we can eliminate the options from here. 1 cannot be the answer. It means our option number A and C cannot be there. So we have remaining B and D option, 2 options. So let us check them. So it is not a state function. 2 is not a state function. 3 is not a state function. It's correct. But what about fourth part? It is a state function because this is equal to G, Gibbs free energy. So 2 and 3 is correct option. Second question, in a closed insulated container, a liquid is stirred with a paddle. So it is closed insulated, means it is an isolated system. It is an isolated system. So in isolated system, no matter transfer, no energy transfer will take place at all. That change will not, that will be equal to 0. No change will occur at all. No heat will be transferred. So from these options, from these 4 options, we can eliminate. This is Q is not equal to 0. This is not equal to 0. So this is not correct because this is isolated system, closed system. So option number, these Q is not equal to 0. These 3 options contain this part. So automatically we can eliminate, and the correct option is option A. Now option A, because this is isolated, no heat transferred. W is not equal to 0 because work is done, because we are churning the liquid, okay. And delta E is equal to some energy change will be there. However, there will be no exchange of energy between system and surrounding. Next question, it is correct option for free expansion of an ideal gas. Free expansion, in our previous video we explained that free expansion means your external pressure is equal to 0. So in that, at that time, W will be equal to 0. Your work done will be equal to 0. So correct option we have to opt. Next condition is adiabatic condition. So your W is 0 and your Q is also equal to 0. So your delta U will also be equal to 0. So let us check them. So from here, W is greater than, so this cannot be the option, correct option. So we can eliminate. Now we are remaining with these 2 options, sorry. So it is Q is less than 0, whereas adiabatic, that's why Q is equal to 0. Correct option is option number A. C option is wrong option. Fifth question, under isothermal condition. Isothermal condition means temperature is constant. Gas at this temperature, it is constant, it is fixed 300 Kelvin. It expands from, this is initial and final volume, expansion is there. Against a constant external pressure 2 bar, the work done by the gases, because this is an ideal condition. So we have to use the simple formula for work done, and that is equal to pressure external into delta volume, change in volume. Now because work, and there is expansion of gas is expanding, it means work is done by the system, and by sign convention W is taken as negative. So we can put a negative sign here. So upon putting all the values, external pressure is 2 bar, external pressure is 2 bar, and volume change means V2 minus V1. We can put the values of volume from here. Initial volume 0.1 liter, final is 0.25 liters. .25 final, 0.1 initial liters. So minus 2, and then this subtraction will get 0.15 units bar liter. Next, minus, on multiplying these 2 numbers, we will be getting 0.3 bar liter. Now your answer is in joule. So here conversion factor is also given. 1 liter bar is equal to 100 joule. So we can put the value of bar liter here. This is equal to 100 joule. So it is minus 0.3 into 100 joule. So we will be getting 10, will cancel out this 0 decimal, and remaining 3 multiplied 10, it is minus 30 joule. So this is the correct option. This is your option number B. This is your correct option. A gas is allowed to expand in a well insulated container. Again, insulated isolated system we are considering, against a constant external pressure, and volume changes from this to this. Change in internal energy we have to calculate. So delta U is equal to, we know that it is Q plus W. Okay, now because this is insulation, there is insulation, isolated system we have. For isolated system Q is equal to 0. So what will be the this energy change, internal energy change? This will be equal to 0 plus W, or simply we can say this is equal to work done by the system, because there is further expansion, because initial volume, and it has been mentioned, initial is 2.5 and final is higher, so there is expansion. So by sign convention your W will be negative. So this implies that delta U is equal to minus W. So simply putting the values, this is P external, delta V with a negative sign along with it. So put all the values. External pressure is 2.5 atmosphere, and volume change again V2 minus V1, it is 4.5 minus 2.5 in liters. So upon solving we will be getting into 2 atmosphere liter. So on multiplying these two numbers we will be getting 5 atmosphere liter. Now because again options are in joule, so we have to find the value in joules only. So you have to keep this conversion factor in mind. We have just discussed 1 bar liter is equal to 100 joule, and 1 atmosphere liter is equal to 101.5 joule. So upon putting the values, 101 if we are putting, because there is no fractional number in the option, so we will be getting minus 505 joule. So this is your answer. This is option number B. Next question, equal volume of two monoatomic gases A and B at same temperature and pressure are mixed. Ratio of specific heat in a mixture. So this is asked in 2012 and this is not there in 12th class. So let us discuss Cp, Cv. These are heat capacities. This is a solution for question number 9. And we have to find the ratio of Cp by Cv, and this is for a mixture. What is the value of Cp by Cv? Now you have to remember one that you have to find heat capacity at constant volume for a mixture. Okay, for that what you have to do, you have to apply this formula. And what is the formula? N1 Cv of first gas plus N2 Cv of heat capacity of second gas by Ma N1 plus N2. What are N1 N2 here? These are number of moles or the quantity. Okay, because it has been mentioned here that equal volume means equal number of moles we are mixing, and the gases are monoatomic. So for monoatomic gas, like we have argon, and noble gases we have helium, argon. These are monoatomic. Number of atoms present in the gas is 1. They are not forming molecule at all. For these molecule Cv, the value of Cv is 3 by 2R. So this you have to remember this relationship, 3 by 2R. R is gas constant. From where we are taking it, actually Cv of any atomic gas, any gas, when we are considering, we have to consider its translational motion plus its vibrational plus its rotational motion. Now number of degrees of freedom we have to find. Degree of freedom and that is for monatomic gas. How can, means number of degree of freedom means how can we apply the how can that molecule or atom can show the different motion when it is in monatomic form or diatomic form. Translation motion is always, its value is always 3. Vibrational is 3n plus 2 or 3n plus 3. Okay, so these are the formula. I'm just writing here simple. You have to remember this thing, that CV is 3 by 2 by R for monatomic gas. Okay, so this is for a gas, not for mixture. Now we have to put all the values here. CV of mixture, because N1 and N2, this is taken 1, so we can put the values here. Both are monatomic, so for both gases value will be 3 by 2 R only. So 1 into 3 by 2 R, this is for first gas, this is for second gas, and add their number 1 plus 1, and this will be in denominator. So in numerator it will be 3R and denominator 3 by 2. Now what will be the CP for mixture? Because we know that Cp minus Cv is equal to R. So from here we can find the value of Cp. Cp will be equal to Cv plus R. Okay, so just put value for calculating Cp. So Cp of mixture will be equal to Cv plus R, and Cv we have recently calculated, and it is 3 by 2 plus R, so it will be 5 by 2 R. So now you can divide these two, Cp by Cv. This is 5 by 2 R by 3 by 2 R. So R will cancel out, 2 will cancel out. We left with 5 by 3. Upon solving, it will be 1.666, which is approximately 1.67. So right option is option number D. So these are numerical based question, can consume your time. 10th question, which of the following is correct option for free expansion? Again, free expansion and adiabatic condition. Free expansion means your W is equal to 0 and adiabatic means your Q is equal to 0. So just eliminate the option first. W is not equal to 0. This cannot be the answer. And from we have remaining 3 options where Q is not equal to 0 is in option number B. So this cannot be the answer. So we left with these 2 options. So Q is 0, W is 0. Now what about delta T? Because there can be some, because this is free expansion, but there is work done, expansion is there, so there will be change in temperature. So that's why your option number A is correct, option C is incorrect. Now we left with the last slide, and first question is which one is true about this reaction? So this is again enthalpy change expression in terms of delta Ng/RT. So we have to find delta Ng for this equation. Now delta Ng, you have to consider gaseous component of the reaction. So it is on left side number of gaseous components. So you can mark here, this is in liquid state. So you don't need to consider its stoichiometry. It is gaseous. And on reactant product side it is gaseous component, no need to consider its number. So we have 2 on right and 3 on left, so right minus left, it is -1. So what will be the expression? Because delta H is equal to delta E minus delta plus delta Ng/RT. So put the value of delta Ng here, it is delta E minus 1 RT. So this is your right option, option number 1. Next question is, in an endothermic reaction, value of delta H. Just you are asked about the sign of del H for endothermic process. So for endothermic process, your del H is positive. Why is it positive? Because endothermic process is accompanied by absorption of energy. Who is absorbing that energy? Energy is being absorbed by the reactant molecule. So if you are taking reactant and they are converting into product, so initially let the energy of a reactant is 10, and if it is absorbing 5 kilojoule per mole of energy. So final energy of this product will be 15. So what is the enthalpy change at del H? This is equal to right minus left, H of right minus H of left. This is actually H, okay, enthalpy, energy. So it is 15 minus 10, so it will be always positive. So this is for endothermic process. Last question is 1 mole of an ideal gas at 300 Kelvin expanded isothermally from an initial volume 1 liter to 10 liter. The del E of this process is. Now thermodynamic is quite easy branch. You have to focus on the processes, isothermal process. So in previous video I told you that for if your process is isothermal, your del U will be equal to 0, your del H will be constant, okay, it will not change further, means del H is also equal to 0. So these conditions you have to keep in mind. So no need to solve this question further. So you can opt from here because change in internal energy will be equal to 0 only. No need to solve it. So this was all for the day. Thank you so much.